Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about Python for machine learning and data science, and in this tutorial we will study about applying functions to a data frame. So we can apply functions to values in a data frame with the help of a function that is named as apply. Okay, so let's define two lambda functions first. Import math square root that is equal to lambda mat.square root x if x is greater than 0, else it is x. So here we are defining a lambda function, and sq underscore root is being defined by it in such a way that we are taking a function that is mat.sqrt from math library, and here we are giving the value of x, and square root has been calculated for the values which are greater than 0, as it will remains the same. Okay, so this is for the square root. Now if you want to calculate the square, so we have again defined a lambda function in such a way that sq equal to lambda x, that is x square. Okay, that means x to the power 2. It is important to note that the objects passed to the apply function are series objects. Okay, it's not a data frame, it's a series object whose index is either the data frame index, that is x is equal to 0, or either the data frame's column, that is x is equal to 1. Okay, now we can also apply the functions to the data frames. Okay, so here we need to use apply sq underscore root, that is the square root function, to the column B if we are creating a data frame. Then we are applying a square root function to the column B in a data frame in such a manner that we'll use df.b.apply sq underscore root. Okay, so let's consider an example, then we will understand how to perform this thing. Import pandas as pd, that means for creating a data frame we are taking pandas module in a form of an alias pd. Import numpy as np, that is for arrays, multi-dimensional arrays. Again we are taking this module in a form of an alias np. Then we are importing math because we need to define the lambda functions. So here are these, that is sq underscore root lambda x mat.sqrtx, and if the value is greater than x, then we will calculate the square root, else we will return the same value. Here we are calculating the square, that is sq equal to lambda x, that is x square. Okay, so these two lambda functions we have defined. Then we are creating a data frame, that is df equal to pd.dataframe np.random.randn 10,4. That means we are creating a table or a data frame in a form of a random numbers, that is there will be a random distribution which comprises of 10 rows and the 4 columns. Okay, and each column we will name it as A, B, C and D. Okay, then we are printing the value of data frame here. Okay, and then we are applying the square root to a particular column. Here it is B. Okay, so we are printing df.b.apply. Okay, so we have to use apply method here, and in apply we are giving this lambda function value, that is sq underscore root. Okay, so it will calculate the square root of the values which are present in the column B. Similarly, we are also printing a value of df.b apply sq, that means it will calculate the square of the values which are present in the column B. Okay, so let's save this code and run this code. Alright, so here it is. This is the data frame. Okay, and then this is the square root of the column B value. So what are the values which are present in the column B? We are calculating, here it is, this is the column B. Okay, these are certainly the values. We are calculating the square root of it, and here are the values of it, and then we are calculating the square of the values which are present at column B. So here is the result. Okay, now if we apply sq underscore root function to the data frame, okay, instead of using a column, if you want to calculate the square root of the complete data frame values, so if you just want to apply this thing, that is df.apply sq underscore root, so we will get an error. So again, just consider this code and try to apply this thing. That means instead of using df.b, we are using df.apply, and we are removing this line. Okay, so let's save this code and run this code. So here we got the data frame. If we talk about the square root of the data frame, so here is an error. This is a value error. Okay, and yes, we cannot apply this thing to the data frame directly. This is because the object which is passed into apply function in this case is a data frame, not a series. If it would have been a series, definitely it will print the value as it did in the previous example when we are taking column. But now it's a data frame, it's not a series, so that's why it's giving an example. But interestingly, there is one case. If we are using square function to the data frame, let's see what will happen. We are applying the square to the data frame and we are removing the square root statement. Okay, now let's save this code and run this code. Here we got. This is your complete data frame, and we got the square of each values which are present in the columns. Okay, or we just say which are present in this complete data frame. If you want to apply the square root function to the data frame, what will happen? Because we did try it, it has given an error, but once it can be done with a series. So what's the alternative method? We can iterate through the columns and apply function to each column. Okay, so instead of giving a complete data frame, we just perform the iteration here. So how to do this thing? Let's consider a code again. All right, so the code is completely the same till here. Okay, we need to perform the iteration. So let's consider the iteration for respective columns. Okay, for column in df column equal to df column dot apply square root. Okay, so we are just taking the iteration one by one for each columns. That means A, B, C and D. We are applying the square root, and then finally we are printing the value of the data frame or the updated data frame. Okay, so we'll start with the column A, then we will apply the square root on the column A, then we'll take the column B, apply the square root of all the values of the column B, similarly on C, and then on the D. Okay, and finally once the square root of all the column values has been calculated, we are printing the value of data frame. Okay, we can also print the value of df here. Okay, so here it is. Now save this code and run this code. So here is your data frame, okay, this one, and here is the square root of the data frame, which we did calculated respectively by calculating the square root of each column values. Okay, now so we can apply function to either of the axes. That means to, if we just give an index, that means the 0 value, it can be applied to each column, and if we give 1, it can be applied to each row. Okay, so for the two particular lambda functions just we have seen now in the previous examples, it doesn't matter which axis we are applying for it, the result will be the same. So for some of the functions, the axis that we apply, it does matter, but the lambda functions which we did consider here, it doesn't matter. Now for example, let's consider the following statements where we are using the sum function from the numpy. So essentially we are summing up all the values which are present in each column. Okay, so here we are taking the value of x's is equal to 0, and if we set the value of x's to 1, and then we will perform this operation similarly as we did above. Now there will be a change. That means we are applying the function to each row. Previously we are applying the function to each columns. Okay, so it's been giving the values for the summation of each column values. Okay, so let's consider a code, and we will include both these statements in this code. Okay, so here it is. All right, so this is the code which will all same till here, where we are creating a data frame and printing the data frame. Only the matters are the last lines. In the first line, we are applying, that is print df dot apply np.sum x is equal to 0. So this is for the columns. Okay, we will calculate the sum of all the column values, and then the next is df dot apply np.sum x is equal to 1. So here we will calculate the sum of all the row values. Okay, so let's save this code and run this code. So here it is. Obviously this is your data frame. Okay, and here is the sum of all column values. Okay, so yes, the sum has been calculated. Here are the 10 entries. So the sum has been calculated for A, B, C and D, and these are respectively the values for all. And then similarly in the next we are printing the sum of all the row values. Okay, so these are respectively the row values. Okay, for 0th index, for 1th index, for 2nd index, and as there are about 10 index values. So here the sum of all 10 index values has been calculated and it has been printed. So this is how we can apply certain functions on the data frames. So that's all for this tutorial. We will come up with more informative tutorials on Pandas. Thanks for watching. Kindly do subscribe to my channel.